So let's look at this equation. Solve the equation 6 minus the quantity x plus 3 equals 2x. Again, I don't like subtraction, so I want to put a plus there. So to make that a plus, I got to make a negative. I don't want that negative to be dangling, so instead of just be dangling, I'm going to put a -1 there to kind of make that work for me. So I can just make that a plus, a -1. So to remove the parentheses, I got to multiply -1 through the parentheses. So 6 is going to come down. This plus is going to come down. And then to remove the parentheses, -1 times x is just going to be -1 times x, or -1x. Plus then -1 times 3 is going to be -3. Then that's going to equal this 2x. Now remember, I have like terms still to deal with on this left side. So that 6 and -3 will go together. So I'm going to have a -1x. That 6 and -3 to go together to give me a +3. Then that's going to equal 2x. So before I go anywhere, I need to make sure each side is simple as possible. So I remove the parentheses. Now there actually are some like terms to put together. So I have now this -1x plus 3 equals 2x. Now, I need to get the variable on the same side of the equation. So I look at, this is a -1 and this is a 2. -1's what is considered the little guy. So I want to use its zero pair. So the opposite of a -1 is a +1x. So I add a 1x over here as long as I add a 1x over here. Keeping that 1 there just really helps things stay visible. So the -1 and the 1x will zero out. So this is going to leave me a 3 on this side. And 2x plus 1 more x gives me 3x. Again, the goal is to get the x by itself. Since the 3 is a coefficient, to make the coefficient turn into 1, I have to divide by 3, as long as I divide the other side by 3 as well. So 3 goes 3 one time. These 3's divide into 1, but we don't have to write 1x. We just want to write an x there. So x equals 1 would be the solution to that equation. So on the GED, there's a formula sheet that you'll be given, and I will share that with you as well. There's a lot of geometry formulas on the formula sheet that may be useful to us. So we will come across several applications to solve. So in other words, we have some word problems to contend with. So let's look at this word problem here. So we have a horticulturist marks off a 32-meter wide rectangular nursery plot with 158 meters of fencing. Because the plants must be properly spaced, she needs to know the length of the plot. Find the length in meters. So when we solve word problems like this, the first thing is to figure out is what's the unknown. And usually that's what you're looking for. Find the length in meters. So the length is what's unknown. And then what we need to know is what is known. So a horticulturist marks off a 32-meter wide rectangular nursery. So what's known is we have a rectangle. So once geometry, it's a good idea to draw the shape, the rectangle. And it says it's 32 meters wide, so this side's going to be 32. And we also know that there's 158 meters of fencing that's going to go around the plot. So there's 158 meters of fencing. So that's also known. And then the relationship. So how does all this go together? Well, what I'm picking up on is I have a rectangle to start with, and the fencing is going around the edges. So if you're going around the edges, we're talking about the perimeter of a rectangle. So the relationship is going to be is perimeter. So we know that the perimeter is going to be determined by going all the way around. So what that means is we have to have 2 widths, and we also have to add to that 2 lengths. since there's four sides on a rectangle. So in this formula, we know that the perimeter is going all the way around, and that's what the fencing is going to do. So we know that in this relationship, the perimeter is the fencing itself. That's going to be the 158. So I'm going to replace the perimeter with 158. The width was 32, so that's going to be 2 times 32, plus then twice the length. So the length is going to be what's the unknown. So this looks pretty good. So all we have is an equation to solve to find the unknown. And again, before we start solving things, we need to look at each side and notice that we have the 2 times the 32 to contend with. 2 times 32 is going to be 64. So I simplify the equation down a little bit. So 158 equals then this 64 plus 2L. Now, to solve for L, remember the 2 is the coefficient. The 64 is the piece that's being added. So I need to make a 0 pair there. So I add a negative 64 here, as long as I add a negative 64 to the other side of the equation. So this is going to be different signs. It's going to be subtraction, and that's going to end up being a 96. And over here on the other side, we have the 2L. To make the coefficient go away, we have to divide by the coefficient. So we divide by 2 here as long as we divide this side by 2. So what I have to do is go 2 into 96. And so I can use my long division to do that. 2 goes into 9 4 times. 4 times 2 is 8. My remainder is 1. 2 goes to 16 8 times. 2 times 8 is 16, so my remainder is 0. So 96 divided by 2 is going to be 48. So my length is going to be 48. So I can solve this problem by using a formula if I want to. There's many ways to do it, but that's the strategy I'm going to model here. So if you add 32 and 32 and 48 and 48, that should add up to the fencing of 158. So the answer to this problem should be 48 then. And of course, that would be in meters. So a lot of times on the GED test, the unit will already be present. All you have to do is put the number in, but the answer has to read as 48 meters once you're done. So another word problem, the area of a rectangular plot is 60 feet. Actually, that should be 60 square feet. You look 2 there. Area is in square units. So 60 square feet. If the length of the plot is 10, what is the width of the plot? So the unknown is going to be then what we're looking for, which is going to be the width. What we know is the area is going to be 60 square feet. We also know that the length is going to be 10 feet. Now the relationship again is we're talking about a rectangle. So we know we have a rectangle here. We know the length is 10, and we know the area, the inside of it is 60. And so on our GED formula sheet, we know that the area of a rectangle is going to be area equals length times width. So what I can do is, using this relationship, this equation, I can replace the values that we know. So we know that the area was 60, so I can replace the A with the 60. We know the length is 10, but we do not know the width. That's the unknown. So we have an equation. And to solve for W, since the 10 is the coefficient, we divide both sides by 10 to get W by itself. And 60 divided by 10 would be then 6. So the width would be 6. 6 feet would be the width. 10 times 6 would give me 60 square feet, so that makes sense. So that's how that problem would work out if we're dealing with the area of a rectangle. So the area of a square is 144 square centimeters. Find the length of the side. So the unknown is going to be the side. We don't know how long the side is. The known is going to be, the area is going to be 144 square centimeters. And I also know that I have a square. So a square looks something like this. So we know that to follow this problem, how does a side get associated with the area? Well, on the formula sheet, we understand that the area is going to be the side squared. So the formula is going to say A equals S squared. So in the relationship, though, we know that the area is 144. What we don't know is the length of the side. So if I solve this, we can take the square root, use the inverse operation. The square root of 144 is going to have to be what S is. Well, I know that 10 squared is 100. So the answer's got to be more than 10. So if I try maybe 12, 12 times 12. This is looking pretty good. So 12 would be the value of S. Now remember, an equation like this actually has two values that work. 12 and a negative 12 would actually solve that equation, but remember we're talking about a rectangle or a square now. A square cannot have a negative length, so even though negative 12 solves this equation, negative 12 does not solve our problem. 12 would solve our problem. 12 centimeters would be the length of the side. So the negative 12 would have to be rejected because the side of a rectangle cannot be negative. So 12 centimeters would be your solution to that problem. So this application is going to involve the Pythagorean Theorem, which is a squared plus b squared equals c squared. It's going to be a very special formula, and it is on your GED sheet. It's kind of towards the bottom of the GED sheet. The Pythagorean Theorem works for right triangles. So you have to have a right triangle. So a triangle is a three-sided shape, but it has to have what we call a right angle in it. So the Pythagorean Theorem is a formula that works for what we call a right triangle. The A and B are the sides that form the right angle, and C is the long slanted side. So this drawing right here, you know, the A and the B are the sides that make the right angle, and the C would be the slanted angle. If I look at this right triangle, the A and the B are the right, they form the right angle, which is here, and then the C is the slanted side. This right triangle here is kind of going in another direction. But notice there's the right angle, and A and B are the sides that make the right angle, and the C is the slanted side. As long as you have the A and B next to the right angle, it doesn't matter who you call A and who B. They just have to be adjacent to the right angle. And the C is the slanted side. So in this problem here, what you'll see is it actually is going to involve the Pythagorean Theorem. You can kind of see, just looking at the drawing here, there's this right triangle involved, and there's some markings on the sides. So that's going to be kind of a clue that this could be the Pythagorean Theorem. But here's the actual word problem. A light pole will be braced with a wire that is to be tied to a stake in the ground 18 feet from the base of the pole, which extends 26 feet above the ground. If the wire is attached 2 feet from the top, how much wire must be used to brace the pole? So the unknown is going to be the wire. We don't know how long the wire is. The known is we got a stake that's 18 feet from the base. So there's a stake that's 18 feet from the base. And there's also, the pole itself is 26 feet, is the pole. but the wire is going to be 2 feet from the top. I'm going to kind of abbreviate a little bit here since I'm writing with this mouse. So the relationship we have to pick up on is we see that from our drawing, they helped us with already is we have a right triangle. And what we're looking for is the wire, which is going to be the slanted side of the right triangle. And where the stake is how far it is from the pole. That's going to be a distance of 18 feet. And we also need to know this side of the triangle as well. So this is going to be the Pythagorean theorem. So this is going to be the a squared plus the b squared is equal to c squared. So a is pretty clear. That's the 18. So I have 18 squared plus then the pole is not what we really use. It's notice how the wire actually attaches right here. The other 2 feet goes above the wire. So we have to actually remove that 2 feet off the 26 feet. So this side here actually turns into a 24. So we have a 24 squared. And then that's going to equal then your c squared. So that's some big numbers here. We may have to use your phone or a calculator, wherever you got. On your phone, you may find a calculator. So let's see if I can get that pulled up here. And if you turn your phone slantways, it gives you more of a graphing calculator. So 8 squared or 18 squared, I think I'm just going to put 18 times 18 in. I don't really see anything on mine. If you see a square button, you can use that. That's going to be 324. (24 squared), I don't see that very clearly, so I'm just going to put 24 times 24 into my calculator. That's going to be 576. And that has to equal then c squared. So remember, with an equation, you have to simplify. So I'm going to go ahead and add the 324 to the 576. I'm using my calculator there. That's going to give me 900 equals then c squared. And so, again, I can use the inverse operation to solve this if I don't want to guess and check. I could just guess and check. But I also can just go the square root of 900. On my calculator, I do see that symbol, so the square root of 900 equals 30. Yeah, 30 times 30 does give me 900, so that seems to check. So 30 would be the length of the wire here. So 30 feet would be the answer to this problem. And when you get all over the place like I just did, you know, a good idea is to circle your interest, say, here it is, flag it out there. So that's how that problem will be solved using what's called the Pythagorean theorem. So this is our last slide, and we want to find the missing side of a right triangle. So our clue again is right triangle and sides. So this means I can draw a right triangle. I'm going to just do the best I can here. So the unknown is going to be one of the sides. The known's one of the sides is 9, and we know that A is one of the sides that makes the right angle, and B is the other side that makes the right angle, and the C is the slanted side, so 15 has to go over here. So I can show my knowns and my unknowns and my whole relationship just in a drawing. So a squared plus b squared equals c squared is on the GED Formula Sheet. So then if I substitute in, the a I can say is 9 squared plus then b squared, and that has to equal then 15 squared. So again, if we have a calculator available, we can just do 15 times 15, or that's not really hard to do it without. But so that's going to be 225. 9 squared, I know 9 squared. 9 squared is 81. So I can replace that with 81. Plus then this b squared. And that's going to equal then this 225. Again, to solve for b, this is a little bit different, but I still want to do the same thing. I want to make the zero pair to start with the piece that's being added. So I want to get the 81 out of the way to start with. So the zero pair of an 81 is going to be a negative 81. So if I put a negative 81 there, I can add a negative 81 over here. So the b squared comes down. And then we have different signs, so that's subtraction. So it looks like 144. And then I have to find what b is by taking the square root, because remember I have to use the inverse operation. I think we did that one earlier. The square root of 144 should be the value of b. And that's going to be 12. So the missing side would be 12. So again, if you write down the equation, you can then use your abilities to solve equations to find the missing value. So that concludes our lesson for the day.